Okay, so the topic for this lesson is limit definition of derivative. So in the previous section, we learned that average rate of change is given by this function, which is interpreted as slope of a secant line, and the instantaneous rate of change is given by this expression, which is actually the slope of the tangent line. So what is derivative? Here is the definition. So derivative of a function f of x at x is the new function denoted by f prime of x. This is a new function denoted by f prime of x, which is given by this expression if the limit exists. So in fact, the derivative is actually the instantaneous rate of change of a function at x, or it is a slope of a tangent line. Now, a couple of things to remember. So when we look at this expression represents the slope of a secant line, and this can be interpreted as average rate of change, average velocity in terms of, if you're looking for speed, average rate of change in cost, revenue, or profit in economics. That is the application. Now, when we have this expression, f of x plus h minus f of x over h, limit s tends to 0, then this expression represents the slope of the tangent line, and instantaneous rate of change, or instantaneous velocity, or marginal cost. This is a very important word in economics. Okay, if you want to find the marginal cost, marginal revenue, or marginal profit, basically you need to find the derivative. So derivative has a different notation. Leibniz notation for derivative is df over dx, or dy over dx. Newton's notation for derivative is y, the over dot. Lagrange's notation for derivative of a function is f prime of x, and Euler's notation for the derivative of a function is d sub x f of x. So among this, we mostly in this course will be using either this, or this, and some as well. Okay, we rarely use the Newton's notation derivative. So in order to find the derivative, using the limit definition of the derivative, I suggest you follow this three-step method. Step 1, you find f of x plus h and simplify, then write the definition of the derivative, which is this, and then substitute the values of f of x and f of x plus h and f of x, and evaluate the limit. So let's look at this part A, example 1. For each of the following function, find the derivative f prime of x using the definition of the derivative. Please remember, when I say definition, you must use the definition. Some of you might have done this derivative in high school and you tempted to use the shortcut method, the formula for derivative. And please don't do that. Whenever you see the word using definition, we must use this definition to evaluate the limit here. We will learn the shortcut technique later in the next section, okay? Next lesson. All right, so we have this. Now, following the three-step method, first, you find the step 1. Find f of x plus h, which is 6 minus x plus h squared. And if you simplify, you're going to get 6 minus x squared minus 2xh minus h squared. So that will be this. And step 2, write the formula. So formula for derivative is f prime of x is given by limit s tends to 0, f of x plus h over f of x over h. So that is the definition for the derivative. And step 3, plug in the value of f of x and f of x plus h in step 2. So we have f prime of x equals limit h tends to 0. Just substitute the value. F of x plus h is right here. So we substitute that value. 6 minus x squared minus 2xh minus h squared minus f of x. So f of x is right there. Minus x minus, and this negative you need to change the sign, and over h. Now simplify, evaluate the limit. That's it. The 6 cancel out, x squared cancel out. In order to evaluate the limit, you may want to plug in the value of h directly. That's going to give you 0 over 0. That means we have to do some algebra. And the easiest algebra here would be just factor out h. So now you plug in the value. So you're going to get negative 2x plus 0 equals h. Sorry, 2x. So the derivative is 2x. Negative. Let's try one more. We are given f of x is 4 square root x. So step 1. Find f of x plus h, which gives me 4 square root x plus h. Step 2, write the formula. F prime of x equals limit h tends to 0 . Step 3, substitute the value. So you have f prime of x equals limit h tends to 0. This 4 square root x plus h minus square root x, f of x, over h. So you can take that 4 common. So you have limit h tends to 0. Now recall from high school, whenever you have these kind of expression, how did you simplify it? Well, by multiplying the conjugate, right, in order to evaluate the limit. Because when we plug in the value of h directly, you're going to get 0 over 0. So it means we have to do some algebra. And the easiest algebra here would be multiply top and bottom by the conjugate of that. So that means multiply top and bottom by this and simplify. So you're going to get so the top part you can use a minus b, a plus b, a minus b times a plus b, which is a square minus b square over h times, look at that. Now your job is to simplify the square root, and the square is gonna cancel out, so you're gonna left with and simplifying, you get this. This cancel out. So you have, now you can substitute the value of h. So you will get 4, 1 over square root x plus 0 plus square root x. So that's going to give me 4 over 2 root x, so that is 2 over root x is your answer. All right, so in the same manner, you can do this part C. I leave it to you. You can try that just for fun, but the process is same. Just follow that 3-step method. Okay, example 2. Consider the function f of x equals 6 minus x squared. Here we need to find the equation of the secant line through the points where x has the following values, x equals -1 and x equals 3. In part B, we need to find the equation of the tangent line when x equals -1. Okay, now recall from your high school that to find the equation of a line, what we need is we need two things. One is slope of a line and then a point, so that we can use the formula y minus y1 equals m times x minus x1. Okay, so basically what we need is we need the slope and we need a point. Now in part A, because x value is given, x equals -1, when x is -1, what is your y value? Well, you just plug in that. Y means f of x. So y equals f of -1, and that gives you 5. If you just plug in the value there, so we have one point as -1 and 5. And when x equals 3, and your y coordinate will be f of 3. And if you substitute that value in the function, you're going to get -3. So this is another point. So basically, we need to find the equation of a line passing through these 2 points. So we already have the point here. This is my x1, y1. I can denote that by x1, y1, and I can denote this as, let me write this way here, equals x1, y1, and this is x2, y2. So first we need to slope. Let us find the slope here. Slope is y2 minus y1 over x2 minus x1, and that's gonna give me -2. And now we have slope, so equation of secant line is given by y minus y1 m times x minus x1. So let us plug in the value. So y minus y1, as you can see, y1 is 5 here, right there. This is your y1, equals m is -2, x minus x1 is -1. So y minus 5 equals -2x and -2. So this gives me y equals, if you simplify it, you're going to get 2x plus 3. So this is your equation of the secant line passing through x equals -1 and x equals 3. Now the part B, we need to find the equation of the tangent line at x equals -1. We need to know a point and the slope. Remember, we need to know a point and the slope. So the point when x equals -1, the point is y equals 5. We have the point here already, which is, let us denote that by x1, y1. Okay, when x is -1, y is 5. We already calculated that before. Now here, we as soon as we find the slope of the tangent line, then we can find out the equation. So slope of the tangent line is basically the derivative. Okay, derivative of the function at that point, x equals -1. So to find the derivative, okay, slope of the tangent line, the derivative, and I believe we have already done the derivative of this function, x6 minus x squared. We have already done in example 1a, and I'm just copying the same step that we have done. Okay, this is, let me just copy and paste here all the process. This is the process that we did. So what we got is we got negative 2x as our derivative for that function. So when f prime of x equals negative 2x, then when x equals negative 1, then you can find f prime of negative 1 is 2. So the slope of the tangent line m equals 2. Now we have the slope, we have the point. So we will find equation of tangent with slope m equals 2 and passing through the point negative 1, 5. We suppose that to be x1 and y1. And we know the formula from high school, which is y minus y1 equals m times x minus x1. Substituting the value y minus y1 is 5 equals m is 2, x minus x1 is negative 1. So if you simplify, you're going to get y minus 5 equals 2x plus 2, which gives me y equals 2x plus 7 is the equation of a tangent line. Okay, we know how to find the derivative and we know the meaning of derivative. Now the question is where a function is not differentiable. In another word, at what point the function cannot have the derivative. Okay, not differentiable means where the derivative does not exist. There are three situations, three conditions where you cannot find the derivative of the function. So for example, remember the derivative represents the slope of a tangent line. So when the function has a sharp corner, like in this sharp corner, okay, this is your figure A, figure B, and figure C. In figure A, sharp corner. So in this case, there is no well-defined tangent line, because if you draw a tangent a little bit on the left side, from that point, the left-hand derivative will be that. And if you look at a little bit on the right side, so the right side tangent or right side derivative, tangent will be that. So they are not the same. They are not equal. Therefore, therefore the derivative doesn't exist. In another word, there is no one well-defined tangent line at that point. Okay, the same thing here. Sharp corner, no derivative exists. Second condition. The second condition is a function f of x is not differentiable at a point where there is a vertical tangent line. Because you know that what is the slope of vertical line? You know that the slope of vertical line is always undefined, right? Slope of vertical line is undefined. Let's say this is x equals 3, then what is the slope of that line is undefined. We know that. So at this point, when you draw a tangent line, you're going to get a vertical line. So we know that the vertical line slope is undefined, so derivative doesn't exist at that point. Because derivative means it's the slope of the tangent line, right? And the third situation where derivative does not exist is at the point of discontinuity. Okay, look at this graph. In this graph, the function is discontinuous when x equals negative 2. Okay, the function is not, f of x is discontinuous at x equals negative 2. Therefore, if the function is discontinuous, that means the function is not defined at that place, okay, at that point. If the function is not defined, there is no questions of drawing the tangent line because the point is not there. Okay, so You cannot find the derivative at the point where the function is discontinuous. Let us look at this example 3 very closely and see at what point this function does not have the derivative and what is the reason why the function doesn't have the derivative. So as you can see in this example, here at x1, at x equals to x1, there is a sharp corner. So if there is a sharp corner, no tangent line possible. So the function doesn't have the derivative at that point. In the same way here also, it doesn't have the derivative. At this point, the function does not have the derivative because there is a point of discontinuity. At this point, x4, the function does not have derivative because, again, it's because of the discontinuity. Okay, the function is not defined there. It's a point of discontinuity. And at x5, again, the tangent line is a vertical line, therefore derivative doesn't exist at that point. And here again the function is discontinuous at x equals 6, so the derivative doesn't exist. Now one simple example, okay? Suppose you are given a function f of x is x squared. This is, let's say, x squared minus 1 over x plus 2. Find the points where f is not differentiable and why. Can you try this for me? So in this case, when x plus 2 equals 0, f of x is undefined. And also you can say or discontinuous. Okay, the function is discontinuous. That means x equals -2. So at x equals -2, f of x is not differentiable. So the temperature T in degree Fahrenheit is the function of x here, which is T of x given to be 0.002 x squared minus 5x plus 1. And to find the derivative of that function, then we will follow those three-step method. Step 1, you find x plus h. And if you simplify, you're going to get step 2, write the formula. And plug in the value. and simplify. And evaluate the limit. So our derivative is going to be so what does that mean? So this represents the change in temperature. So the meaning is the change in temperature x feet above ground is given by 0.004x minus 5 degree Fahrenheit per additional feet. Okay, so it represents the rate of change. So the change in temperature, x feet above ground is given by, this is a very general one, x. Now in part B, what we need to find is when in part B we need to find T prime of 100. So when x is 100, so this is going to be 0.004 times 100 minus 5. And that's going to give you negative 4.6. So what this represent is, the meaning is the change in temperature x feet. Now this 100 feet, okay, just replace that x by 100 feet above the ground. Above the ground, just copy the same thing. Above the ground is given by, above the ground is decreases by, because of the negative sign, decreases by 4.6 degree Fahrenheit per additional foot. Okay, so the derivative as a function. We now know how to find, or at least approximate, the derivative of a function for any x value. This means we can think of the derivative as a function too. So the graph of a derivative of a function f of x is related to the graph of f of x. And how they are related? Well, the input will be the same x, and the output is actually the derivative. So that means this will be x and f prime of x. Okay, in the function, general function, we have x and f of x, but now x will remain the same and y value will be this. Here is one example what I mean. The figure below is the graph of a function. Okay, so the graph of a function, this blue curve, y equals f of x. Using the information in the graph, fill in the table showing values. Okay, let us fill this table in. So in this table, when x is 0, this point, your y is also 0. When x is 1, let us fill that y value first. When x is 1, then what do you get? Y is 1. When x is 2, y is 0. When x is 3, y is -1. When 3.5, this will be 0. When x is 4, it may be maybe 1.8 approximately. And when this is 5, it is maybe not 1.8, 0.8, I mean 0.8 approximately. And then 5, this is 1 point maybe 7 or 8 approximately. Now let us estimate the slope of the tangent line at each of these points. Okay, so in this case, in order to draw the graph of a derivative function, so we're going to draw the graph of a derivative function. So what I suggest to do is, at various values of x, draw your best guess at the tangent line, okay, and measure its slope. You might have to extend your lines so you can read some points. So in general, your estimate of the slope will be better if you choose points that are easy to read and far away from each other. By the way, here are my estimate, okay? I'm gonna choose a couple of points in order to draw the tangent line and measure the slope. So the one point that I'm choosing is this one at x equals 0. Another point is here at x equals 1 and y equals 1. Another point at x equals 2, y equal to 0, and so on. So these are the points I'm choosing, okay? You just choose a couple of points randomly, but choose the point that makes life easy, that makes, the estimation of this slope of the tangent line easy, all right? Again, to draw the accurate graph, it's really difficult. But as long as you draw a approximate graph, roughly sketch the, just sketch the, graph of the derivative, it should be fine. Now, okay, so here are what I did here is, let me look at this. At x equals 0 and y equals 0, if I draw the line, as you can see, so this tangent line looks to me that rise is 1 and run is 1. So the slope is rise over run, so 1 over 1. So at this point, the slope of the tangent line is 1. Okay, approximately. You can write 1.1, 1.2, 0.9, that's fine, but approximately 1 to me. Now, another point that I want to choose, easy to figure out, is this point right here. If I draw a tangent line at this point, this is a horizontal line, and we know that the slope of the horizontal line is 0. Okay, I'm putting that all the way here in the table. These are this column is for derivative. In the same way, if I look at the tangent line at 2, as you can see at 2, so rise is, okay, rise is this part 1 and run is also 1, but it's going on the left hand direction. So that is rise is 1 over run is -1. Therefore, the slope will be -1. That is the derivative, because derivative means slope of the tangent line. In the same way at 3, if you look at that, so the slope of the tangent line will be 0, and so on. Okay, now in the same way, you can just estimate the slope of the tangent line, and I have estimated at those points, and then let us draw the graph for the derivatives. Now, if you want to draw the graph for that derivative function, then you need to write down, your point will be 0, x is 0, and your y value is 1, 0 and 1. Okay, remember, here we need this. because we're going to draw the graph of the derivative function. So the y value will be the derivative. So the second point will be 1 and 0. Third point will be 2 and -1. Fourth point is 3 and 0. And 3.5 and 2. 4 and 1.2. 5 and 0.33. So on, okay? Now let us draw those points here. So 0 and 1. When x is 0, y is 1 is right there. That is my first point. When x is 1 and y is 0, so that's the point. When x is 2, y is -1, so that's the point. When x is 3, y is when x is 3, y, so this graph should go a little bit this way. There is a little bit of a problem here, okay? So so this is the point. When x is 3, your slope is 0, right there. And when x is 3.5, your slope is, when x is 3.5, your slope is 2, so that is 3 and 2 right there. This is the point, 3 and 2. Okay, and then when it is 4, it is 1.2. So 4, 1.2 will be somewhere here. That's the point. At 4, it is 1.2. And when it is 5, it is 0.3. So 5, 0.3 is somewhere here. So now use your freehand and join all these dots. And then you got the graph for the derivative function. So this is the graph of the derivative function f prime of x.